All right, like I said, 9.3, exponential functions and graphs. All right, so before we actually get into the exponential functions, we're going to learn about a new constant in math, like pi is a constant. Well, when you're dealing with this section, there's a new constant we're going to look at, and this is what we call Euler's number. Okay, so I'll show you what that is on your calculator. But this is the constant they use when they're doing interest type problems, okay? When you're dealing with continuous compounding, and we'll see that later on in the chapter. They use E in them kind of formulas, okay? So all we got to know how to do is approximate it. So what we're going to do, we're going to approximate 4 decimal places. Okay, so you got to get good at rounding in this section. So we're going to round stuff 4 decimal places after the decimal. So you got to look at the 5th decimal place to see what to do with that 4th decimal place, okay? So now let me show you where E is on your calculator. There's 2 places actually. So I'm going to share my calculator. So if you just want E by itself, if you look above the divide sign on the calculator, right above divide, you'll see a blue E. So if we hit the blue second button and then the divide button, that'll bring E on the screen. And if we hit enter, it'll give us what E equals. Now we're rounding at 4 decimal places. So that would be 2.718. The 4th spot is the 2. But y'all, since that 2 has an 8 behind it, we would round that 2 up to a 3 and make that a 2.7183. Okay. Now, the second place to get the E, like when you want to use E with some exponents, if you'll look on the left side, to the left of the 4, there's an LN button. We'll learn about that button tomorrow or later on today. But above it is a little blue E with an X. If you hit the second LN button, that'll bring the E up with the exponent ready to go, okay? So that's the differences on those 2 E's, okay? If you want the exponent, you'll use second LN. If you just want E by itself, you use the second divide, okay? So this E, when you see curvy parentheses, that means you're approximating the answer or rounding it off, okay? So in these exercises to start, there's going to be 2 problems, and they want you to use a calculator to approximate the exponential expression. And remember, they want us to go 4 decimal places. So y'all, the first one they got is E to the 6th. So really, why don't one of y'all punch in E to the 6th on your calculator and round me out about 4 decimal places? Now on that one, I would probably use the second LN because the second LN gives you the E with the exponent, okay? And y'all, let me share my calculator and I'll show you how I knock that one out. So that is what? E to the 6th. So let me clear my screen. All right, so I'm going to hit second ln. That brings up the e with the exponent. We're going to put in our 6 and hit enter. And y'all look at that. That is approximately 403.428. So the 7 is in the fourth spot. Got a 9 behind it. So we're going to round that up to an 8. So that'll be a 0.4288. So let's see. Jackson, perfect. You got that perfect. Good job. So that'd be like multiplying this e times itself 6 times, okay? All right, now this one they're doing with a negative exponent. How about e to the negative 3.43? All right, y'all, so punch that one in and we'll see what y'all get. Yep. Now we'll show y'all on something on this one. So what do we have? Second ln e to the what? Negative 3.43. Now y'all gonna hit enter. Now y'all, I'm gonna show y'all a trick. If you're sort of weak at rounding stuff off to 4 decimal places, y'all see the mode button right on the top by the blue button? There's a mode button. Watch what I'm gonna do. I'm gonna hit mode. And down here where it says float, that means our calculator's giving us whatever amount of decimal places that it wants to. But since we're rounding off 4 decimal places, I'm going to go to the right and highlight 4 and hit enter. So now by putting that black mark on the 4, my calculator is going to round me off to 4 decimal places. So y'all want to clear that now. And now you see my answer. I'm going to hit enter and look what it did. It rounded that big old number off into 4 decimal places, which is 0.0324. Okay, y'all, so like I said, if you don't want to have to round them off yourself, go to your mode and set that on 4. Now, if you're doing any other problem, I would probably set it back to float by just coming down here and going back to float and hitting the enter. And then clearing the screen, okay? Because later on, it might mess up some of your calculations if you round off too much. So for right now, when you're rounding off to 4, you can set the mode to 4, go through it, and get them answers, okay? All right, so that's just a little bit about the constant E. So if you're doing business calculus or something like that, you'll probably play with the E a whole lot in that class. All right, so what we want to start looking at is the graphs. So graphing exponential functions. So those are graphs that look like y equals a to the x. The exponent is now the variable. So a is what we call the base. X is your exponent. And then y is your result. Okay, so the base will be some number, and the variable will actually be the exponents, okay? So a few things about these graphs. Well, y'all, no matter what this base is, if I put a 0 in for the exponent, what will that equal? So I'm looking at stuff like 2 to the 0. What does that equal? 5 to the 0. What does that equal? So y'all push them in and see what that equals when you got 2 raised to the 0 exponent, or even 5 raised to the 0 exponent. Actually, y'all can do any number to the 0 exponent. And guess what it's going to equal? Jackson, well, y'all got 1. Good job. All right, no matter what the number is, if it's raised to the 0 exponent, it will equal 1. So that means each graph crosses the point 0, 1. 0 for the x when you put it in, 1 for the y value, okay? Another thing about these graphs are continuous. Continuous means there's no asymptotes because of it being undefined. They're continuous, which means they make a nice smooth curve, okay? Now, they form a horizontal asymptote with the x-axis. On one end. So one side of the graph is going to try to be hugging those x-axes, okay? It just depends on whether this a is a integer or if it's a fraction, okay? So let me show you the two types of graphs based on what that a looks like. So if we have y equals a to the x, those graphs well, y'all, let's just think about it. Let's just play with a few numbers here. Well, if x is 0, anything to the 0 power is going to equal 1. So here at 0, 1, we would have a point. Now, anything to the first power, a to the first power, no matter what a is, if you raise it to the first power, it will be itself. Okay? So that means over here at 1, whatever a is, I'll be up to that point. If I put a 2 in for the x, I get a squared. Well, y'all, a times a is a squared. So if this was a, and I'm moving over to the next value of 2, well, if you square a number, it's going to get a lot bigger quicker. Okay? So what's going to happen, since one side hugs the x-axis, this one, since the right side's going up towards infinity, that means this left side is going to try to hug the x-axis. It's going to cross at 0, 1, and then your graphs are going to curve upward. So if this was, say, a was 2, 2 to the first is 2, 2 squared is 4, 2 to the third would be 8, 2 to the fourth would be 16. So the bigger that exponent gets on this side, this thing's going to shoot towards infinity, okay? Now, on the left side, if these were negative exponents are really what you would call fractions in disguise. So let me show you how that is. Let's say A was a -1. So I'm just going to show you how this side's getting closer to the x-axis. All right, so to make an exponent positive, you put the whole expression under a 1. So you don't change nothing but the sign of the exponent. So that's how their exponents tend to disguise. And then 2 to the first on the bottom, this just gives me 1/2. So over here at -1, I would be at 1/2. So see how it's coming down? Say x was a -2. Well, I'd make the exponent positive by putting all that under a 1. Now that the exponent's positive, 2 second is a 4. So 2 to the first was 1/2. 2 to the -2 is a 1/4. So it's getting closer and closer and closer as the x's get more negative, okay? So y'all, that was just a little review on negative exponents. But you can punch negative exponents in the calculator and it'll give you them type answers, okay? So the other thing that can happen on these, what if my A is actually a fraction here? So if it's a fraction, let's see what happens. Well, any fraction to the 0 power, we said anything to the 0 power equaled 1. So they're still going to go through 1. They all go through 0, 1 on the y-axis, unless we move them around, and we'll learn that later on, okay? Now, if that's a 1, and say this is 2/3, 2/3 to the first would be 2/3. So see, this side is going to want to shrink down towards that x-axis. Because if this was 2/3 and the exponent was 2, you square the top and bottom, that'd give you 4/9. Well, 4/9 would even be closer down, okay? Now, on the left side, these are going to want to come in from infinity. And then y'all, this side is going to try to keep getting closer and closer to the x-axis as these exponents get bigger, okay? Now remember, the left side goes towards infinity, because if these were negative exponents, you would flip the fraction to make it a positive exponent, then evaluate it. So y'all don't have to know all that. I just wanted y'all to see how these graphs got their shapes. So if you got integers, they're going to sort of go uphill left to right. If you got fractions, they're going to go downhill left to right. Because the next few examples, they want us to graph and pick a picture. So let me ask y'all, do y'all got your calculators? Because I'm actually going to have some of y'all picking my pictures for these, okay? So these start at number 3. All right, y'all, so number 3, y equals 2 to the x. A, B, C, or D? And y'all, there's only one of these that looks like what we said it had to look like. Right? We weren't drawing no straight lines on these. We weren't graphing parabolas. This line is going uphill, but it's curved wrong. And remember, ours didn't even cross under the x-axis. So y'all, the only one it can be would be D. Good job. because D is the only one going uphill left to right, and it's crossing over at 1 on that y-axis. So y'all, on that one, you just pick your 1. You pick your D and check your answer. All right, how about this one? Y equals 5 to the X. A, B, C, or D? All right, so what am I getting? Let's see. All right, so that's y'all, looks like D again, right? That's the only one that's got the right shape, going uphill left to right. Now, y'all remember on all these, all you got to do on these is go to that calculator, go to Y equals, put in your number. So what was that, like 5 to the X? So you hit 5, use the upside down V under the clear button to put in your exponent, and then put in that X. Now, when I graph it, there you go, uphill, left to right. But y'all, the next one is a fraction. So A, B, C, or D on the fraction. So we're getting, looks like some B's are coming in. Good job. Because remember, we're not translating these graphs yet. So these graphs do not cross over the x-axis at the moment. So the difference between B and D went a little too low on that thing, okay? It didn't make that horizontal asymptote. So you would go with B. You are going to check your answer. All right, so y'all, let's see which one this is. A, B, C, or D. Because you got two that are really, really similar. So the only difference is it looks like A, my graph is crossing at 2 on the y-axis. And on B, it looks like that graph is below 1 on the y-axis. So those two are really similar. So let's go graph 2/7 e to the x. All right, so if you want it to look like a fraction, hit alpha y equals and enter. Put in your 2/7. Now, if you don't use the fraction notation, put the 2/7 in parentheses. So do parentheses 2 divided by 7, close parentheses. And then I'm going to hit second ln to get the e with the exponent, and then put in my x. So I now have 2/7 e to the x. We're going to hit graph. And y'all look at that. Mine's going by ones. So that graph is definitely going across the y-axis less than 1. Okay? So when you go back and look at them pictures, we want B, because B was the picture where it's crossing the y-axis less than 1. If you look at A, that thing's crossing, it looks like those are going by 2. So it's crossing at 2. So we're going to pick B and check our answer. All right, so let's go learn about transformations before we play with these ones. Now, way back on test 2, when we did section 7.2, remember we moved the graphs up and down, we moved graphs left and right, and we even reflected over the x-axis. So y'all, now we're going to do the transformations to these exponential graphs. So transformations of exponential graphs. And remember, those are going to look like y equals a to the x. So the first move, we're still going to do vertical transformation. So vertical is your up and down. So that'll be y equals a to the x plus b. So here's my function. If I add a number at the end of my function, it's going to go up or down. So if b is positive, y'all did transformations in 7.2. If that b is positive, am I going up or down? So we're going up. Good job. Which means if b is negative, we're going to go down. Okay. So that move is exactly the same as it was in 7.2. The one that's going to sort of be a little bit different is going to be the horizontal. But y'all, horizontal is really, it's still similar to 7.2 because I'm still attacking the x's, okay? So if I have y equals a to the x plus c. Notice, I didn't add the number at the end of my function. I actually added the number to the exponent. So we're sort of attacking that exponent still, okay? This is going to go left or right. So let's see if y'all remember this. If C is positive, well, back in 7.2, if we had our x inside parentheses and we added, oh, Jackson, you're on it today because guess what? It actually goes left. Good job. Which means if C is negative, we going to the right. So, y'all, guess what? Attacking the x is still sort of backwards what you think. But adding goes left, subtracting will make me go to the right. All right, we can still do a reflection over the x-axis. So to do a reflection over the x-axis, I'll have y equals negative a to the x. I still put a negative in front of my function to flip it over the x-axis, okay? So the new one is that we can now reflect over the y-axis. So y'all watch this. To reflect it over the y-axis, we would have y equals a to the negative x. So if I make the function negative in front, it's going to reflect it over the x. If I make the exponent negative, it's going to flip it around and reflect it over the y value. So if it was going uphill left to right, when you make the exponent go negative, it's going to sort of turn it around and go the other direction, okay? To where making the function negative. If it was going uphill like that and you reflect it over to x, it's going to sort of look like that. Okay, so negative function flips to x, negative exponent flips to y, okay? Now, I'm going to show you how to do these on MathLab, because on MathLab, when it pulls up the little extra boxes for us to do our moves in the bottom left, it'll say base. We got to put the base that matches the base of the problem we're doing, okay? So y'all, let's go to MathLab and play with some of these. All right, so look here. I got f of x equals 2 to the x minus 4. So what is that minus 4 doing to my graph since I'm attacking that x value up there? So that's going to be a horizontal, but the question is left or right? Because they're giving us 4 choices here. So now y'all are saying right. So we're going to come back down and choose D, because that's the one that says it 4 units to the right. And it says start with the graph of y equals blank to the x. We're going to put our 2 there, because 2 was our base for our problem, okay? And then we shift it 4 units to the right. So y'all watch this. You're going to check that answer, put OK. Then it says click to enlarge graph. So click that. We know what the exponential tool looks like. On the second row, it's the second tool that says exponential. Click that, and then you can click anywhere on the graph. At the moment, it's got it going through the 1 on the y-axis. But y'all, we said we're going to shift this graph 4 units to the right. So come down here to your horizontal and move that to a positive 4. So y'all notice it moved my whole graph right. Now, we don't want to hit enter yet. Y'all see in the bottom left corner of that little gray box, it says base. There's an E in it by default. We're going to change that E. So we're going to delete the E and change that to a 2, because 2 was the base of our graph. Y'all, if you don't change that base, it will mark them wrong, okay? So I got my base in of 2. I moved it right 4. So I'm going to save that. And then you're checking your answer. All right, y'all, so let's see what 8 has. So y'all, this one wants me to graph it first. Now, that is 6 to the x minus 4. So if I'm going to be able to graph this, y'all need to tell me what that minus 4 is doing to this graph. So down, good job. So I know it's going down. So we're going to click to enlarge graph. Grab our exponential tool, click on the graph anywhere. We went down 4, so that would be vertical to negative 4. Now, y'all remember, my base was a 6. So down here for the base, we need to change that E to a 6. And then you'll save that. Check your answer. And then it's going to tell us basically what we did to the graph. So y equals 6 to the x. Come pick the graph you started with. And then y'all said shift it down 4 units. So some of these you'll figure out the moves first. Some of these you'll graph and then tell what moves you had, okay? Now, y'all, if there is a tricky one, it's this one right here. So let's see, f of x equals 2 to the 2 minus x plus 2. Now, I'm going to tell you a thing about this one. This one, you could treat like 2 to the negative x plus 2, and then bring down that plus 2. Um, Order don't matter here. So if you rearrange it, you got the x first, because that x is doing something to this graph by being a negative. And this 2 is positive. It's doing something to the graph. And then this 2 at the end is doing something to my graph. So that first 2, since it's positive, it's going to move the graph left 2 units. This negative in front of that x, it's going to reflect over the y-axis. Remember, negative x's reflect me over the y-axis. And then that last one is definitely going to go up 2. Okay? So you sort of got to tell it first what's happening. So let's go back to Math Lab, because we got to graph it first. So we're going to click our exponential tool, click on the graph. So we went left 2, so that would be horizontal to negative 2. We'll reflect it over the y-axis, so come down and highlight that box and check it. And then you said we went up 2, so that would be vertical, up 2. Now the base is a 2, so it's already got my base of 2 in there, so I'm good. It probably saved it from while ago. So since we've done that, we can actually hit save, check our answer. Then it's going to come in and make us tell it what we did. Well, y'all, we went left 2 units. We reflected across the x-axis, and then we went up 2 units. So y'all, it looks like we would go with B on that one. Now C was pretty close, but it had x-axis instead of y-axis, okay? Now y'all, one thing about this one, let me tell you a trick on this. When you're doing your moves, you want to do them in order as you come to them. So I did the 2 first, the negative x, and then the plus 2. The reason I rewrote it here was so that you would realize that the x was actually a negative x, okay? But go in order like we did right here. All right, so final check. All right, so I'm going to do this one. It's another tricky one, sort of. So 2 minus 3 to the negative x. All righty, so let me show you what I would do to that. So on this one, I would definitely treat this like that 2 was at the end. So I would do my negative 3 to my negative x, and then plus 2. You always want the base first on this. So if you got a number in front of the base that's being raised to the exponent, move it to the back. Now, I didn't change the sign of the 2. It's still positive, okay? So look here. We're going to be reflected over the x-axis. We'll reflect over the y-axis. And then we're going to go up 2. Okay? So we're reflecting over both axes because of these negatives. And then that plus 2 is going to move us up 2. So on that one, you want to visualize that 2 being at the back of your equation. All right, so let's go to MathLab and see what they do to that. So first it's got the moves. So we said reflect across the y-axis. We said reflect across the x-axis, and then we said we'd shift it up 2 units. So A and C don't even have it shifting over both of those axes, okay? And that's why they're trying to throw you off by putting that 2 in the front. But remember, 2 minus 3 is like 2 plus the -3, okay? So that base is definitely negative. All right, y'all, so you pick that. And our base we start with, we don't care about the negative, we just want the base. The base is the 3, okay? You don't have to put the negative because the negative is accounted for where it says across the x-axis, okay? So when we see that reflect across the x-axis, we know there's a negative in front of that 3, okay? Now, click your graph. You want to grab your exponential, click anywhere on the graph. You're going to come down here, reflect it across the y-axis. You're going to come reflect it across the x-axis. We're going to move it up 2 on the vertical. And we're going to change that base from an E to a 3. Okay? So you got all your moves. You're going to hit save and then check your answer. All right, y'all. So one more of these, and then I'm going to show you a formula to do the last 2 problems in here. So y'all, let's see what y'all going to put in this blank. And we don't even have to graph it. You just got to tell me what's happening to it. So y'all, in the first blank, you're going to start with the graph of y equals blank to the x. What's going in the first box? All right, so 2. So we're going to put in a 2. Then it says shift it blank 5 units. Well, that 5 is being added to the x. So when you add to the x, are you going down, right, up, or left? So y'all are saying left. Because remember, adding to the x does move me left. And then shift it blank 2 units. And that's being subtracted, so that one's going to go down. All right, y'all, so all right, let me get some of these. Oh, did I have to graph that? And I guess I did. Okay, so we got to graph it. My bad. So click our exponential tool, click on the graph. Let's see, y'all went left 5 on the horizontal. Y'all went down 2 on the vertical. And our base goes from a E to a 2. All right, then save that and check your answer. All right, y'all, so I'm going to get some values down on this one real quick. So let me just write some stuff down. 62,000, 4.5% interest. Quarterly. All righty, so before we can do this problem, I'm going to show you a formula. And the reason we're doing it in this section is because it's sort of what you would call an exponential formula. So our formula is A of t equals P times 1 plus R over N, all raised to the N times T. So since I got exponents on this, this is an exponential type equation. So what this will find, A, So this is like doing an interest problem if you invest money at a bank and stuff. A is the amount in the account after T years. So time is the variable basically on this equation. A is the amount of money that is in your account after so many years. Okay. Depending on what I put in for T, I can figure out what I'll have in 2 years, 3 years, 4 years, or so on. P is the starting principal. How much money are you putting into that savings to grow that interest on? Okay, this is your starting amount. If I invest $5,000, P is going to be 5,000. Okay, now R up here, R is the interest rate. Now, when I put interest rate into this formula, it's got to be in decimal form. They'll give me in percentage form, and we're going to change from percentage to decimal, okay? N. N is the number of compounds per year. Number of compounds per year. So I'm going to give you words like quarterly. Y'all, how many times would it be a year if you're quarterly? 4? Yep, there's 4 quarters in a year. They might use semi-annually. So semi-annually would be 2. So semi-annually is 2. Annually would be once. Monthly would be 6. Y'all, they might even hit you with daily. What's that? 365. So just things like that, okay? Um, so that's how many times the interest is compounded per year. So N is in it twice, and then T is the time in years. Okay. How much time has went by with my money being invested? Okay, that'll tell me how much I got in there after so many years. So we're pretty close to break. So what we got, here's our formula. After break, we're going to come in and knock out the last 2 problems, and then we'll start in our 9.4, okay? And 9.4 is basically a lot of calculator stuff. So y'all, let's see. Yeah, we'll finish this one when we get back from break. So I'm going to pause my video. And y'all, I will see y'all at, looks like 11 o'clock. All right, everybody, I am showing 11 o'clock. So we're going to work the problem that MathLab was showing us. So let me go back to that problem and start our video again. All right, y'all. So they say 62,000 is invested at 4.5% interest, compounding quarterly. So they want us to first find the function that we would use to see how much the investment grows after T years. So for A, they want us to come up with a formula. So y'all, let me show you how we're going to do that, because MathLab's sort of picky about what you put into this, okay? So we will start it with what we got, A of T. That's going to equal our principal. Well, y'all, the principal they gave us was $62,000. Then we got 1 plus R. We got to figure out our R. Well, they said R was 4.5% interest. I'm going to turn this into decimal form. That'd be 4. 1/2 would be 0.5. Okay. Now your calculator, if you did 4 times 1 divided by 2, it'll give you 4.5. Okay. Now, it's in percent. We got to change it to decimal. To change a percent into decimal, you got to move that decimal left 2 places, which means I have to add a 0 and then put my point. So you got to move left 2 decimal places. So that gives me 0.045 for R divided by N. So they said this compounded quarterly. And y'all, what y'all say? Well, go Jackson, you said what? Quarterly equaled 4 times. So there would be a 4 on bottom times 4 times T. So your exponent will be 4 for N again, and then T for time. Now, in MathLab, you got to figure out what is in the parentheses to get the right answer. So you need to figure out what 1 plus 0.045 divided by 4 is. So y'all, let me go to my calculator. I'm going to quit the graph. So I had 1 plus 0.045 divided by 4. That equals 1.01125. You got to write all the digits on this, okay? And then, so you got to figure out that middle and then bring down your 4 times T for your exponent. So this is what you got to put in MathLab, the simplified form of that formula, okay? So y'all, we're going to go put that in. So we had 62,000. And then we had our parentheses. 1.01125. Close parentheses. And then get the exponent and put in 4t. So now we've got the formula in like they want. You can check the answer and get it right. Now we're going to continue. They want to know how much money is in the bank after t equals 0, 4, 8, in 10 years. And they want me to round to the nearest dollar. So that means no decimal places. We're rounding to the nearest dollar, okay? Now, if you was doing this by hand, you would start with zero. A of zero equals 62,000 times 1 plus 0.045 divided by 4, all raised to the 4 times 0. So you put a 0 in for the t, and then you punch that in a calculator and see what you get. Now, since we got to do 4 values, I'm going to show y'all a quicker way to get them 4 values instead of punching these numbers in one by one. Because y'all, we got graphing calculators. So I'm going to go to y equals, clear that other off. I'm actually going to put in the formula 62,000 parentheses 1.01125 close parentheses. My exponent will be 4 times x. Remember, you cannot use a t in your graph, and you got to make the variable an x for the graph, okay? Now, I'm going to go to second graph and look at the table. So y'all let me arrow down. So there is where t is 0 or x is 0. If I click right, it gives me 62,000. Okay? If I want to know after 1 year, I go down to 1, go to the right. Now notice, if you look at it in the column up here, they're rounded off to the nearest dollar. But when I check on that amount, it actually gives me the whole decimal form of the answer. Okay? Now in MATLAB, we're just going to put in the 62,000, the 64,837 or whatever. But I just want y'all to see that if you do want to have it in decimal form, you can click on the Y value, and down below it will give you the decimal approximation of them, okay? All right, so let's see. We had to start with t equals 0. Well, t equals 0, we got 62,000. And then they said t equals 4. So let me go down to 4. Whoops. So at 4, I got 74,153. Then they did 8. At 8, I got 88,688. So this is going up over time like it should. And then at 10, I got 96,991. So, y'all, what that means is if I invested $62,000 at 4.5% interest, compounded quarterly, after 4 years, I got 74,000. 8 years, 88,000. 10 years, 96,000. So you've made over 30,000 just letting your money sit in the bank. Okay. So for that, you would just go to MATLAB and you're just putting in those amounts you got. 62,000. Check answer. Then it does 4 years. We had 74,153. And so on, okay? So it'll have y'all do that for those 4 values. And then you'll go to the last problem. And y'all, the last problem's using the same formula. But all you got to do is figure out how much money will be available in an account after so many years. So you're actually using that formula to work a problem, okay? So we're going to get into 9.4 now. And y'all, like I said, 9.4 is going to be pretty much learning the calculator, okay, on how to find what we call logarithms. So these are logarithmic functions. So I will say this, in the long run, the logarithm is basically an exponent. So I'm going to show you some notation here. This is our logarithm notation. And then you'll see a little subscript and then another number. So A, we call the base. Y is the result. Now let me show you something over here. These are undoing these logarithmic expressions. Okay. So here the result equal the base raised to an exponent. So what this is going to find this logarithm, if I know the base and I know the result, if I take the log of a base and its result, it will give me the exponent that the base was raised to. So all this does, this finds the exponent. That the base, and remember the base is the A here, was raised to get the result Y. Okay. So I know the base. I know what the result of multiplying the base was. This will find me that exponent that this base was raised to. It finds you the X. Okay. Now, I'll show you these on the calculator in a second, but I just want to play with y'all a second to see that you got this idea down. So if I have a log base 5 of 25, let me tell you what this is asking me. This is starting with a base of 5. So you got a base of 5 here. We don't know the exponent, but we know that 5 to some exponent equals this result of a 25. So what exponent would this have to be to turn this 5 into a 25? Oh, not 5, because remember, 5 times 5 times 5 times 5 times 5. So there you go. It would definitely be a 2. So since 5 squared equals 25, the log of a base 5 with a result of 25, that would give me 2. Okay? Y'all getting the idea? So let me try this one. How about a log base 3 of a 27? So y'all, what I'm asking you is how many times do you got to multiply that 3 together to make that a 27? What exponent are we raising the 3 to? And that would be a 3. Good job, Jackson. Because remember, this is like 3 to what exponent equals 27? So y'all, you would have to multiply 3 times itself 3 times. Okay? All right. On the calculator, On the front of the calculator, you got a log button. And it's sitting right next to the 7. This log button stands for a log base 10. Okay? So if you got a log that's base 10, you can use the log on front of the calculator. All right, right below that, you see a LN button. LN is a special log. It's a log base E. So it's that little E we learned later. So the LN is a log base E. The log on front of the calculator is a log base 10. So y'all watch this. To do any other logs, we use the log base feature of the calculator. So if I got a log base 5, a log base 3, a log base 2, any other base than a 10 or an E, we're going to use the log base feature of the calculator. So to get to that, you hit Math. So let me show you on my calculator here. So I'm going to hit Math on the calculator. So let me quit this screen. So you hit Math and you arrow down until you get log base. When you highlight log base and hit enter, it brings it on the screen. You'll put in the little base. So remember a while ago I did a base 3 of 27. And y'all watch this. It will give us a 3 like y'all said, okay? So any other log, you got to use that log base. Hit Math and arrow down and get that log base, okay? All right, y'all. So let's think. They start out showing you a few logarithmic graphs. So let me give you all a little information on logarithmic graphs. And then they start finding logs, okay? All righty. All right, y'all. So the logarithmic graphs, when they're drawn, they sort of make an asymptote with the y-axis here. And then they'll come up and then sort of go up to the right. Almost opposite the exponentials. Okay, remember the exponentials came along and went up. These ones do not cross over the y-axis. Because think about this. There's no exponent that can turn a number into a negative number. So if I got a base, I can't turn that base into a negative number by using exponents, okay? Because you got to remember, we're looking at exponents when we do the log graphs. So these will be your graphs of f of x equals log x. Okay. Now remember, if you got a base other than 10, you'll put that base there. But these logs are going to sort of make that graph go uphill to the right. It will not cross the y-axis. It tries to get close to it, but it never can cross it, okay? And then remember, anything to the 0 power was 1 over here. So if you got a result of 1, that means the exponent has to be 0. So it's almost opposite this one, okay? They all cross the x-axis at 1, 0. So they cross x-axis at 1, 0. They are also continuous. So there's no undefined spots on them. They're just a continuous smooth curve. Okay. And they make a vertical asymptote with the y-axis. At one end. Okay. Now, if I reflect it, it'll sort of go down the other way, but it'll still make that asymptote with that y-axis. So, y'all, they're just going to have you graph stuff like y equals log 3 of x. Okay, so you would go into your calculator, go to y equals. So log 3 of x, since that's got a base, I'm going to hit math and go down and get my log base. Hit enter. I'll put in my 3. Then I'm going to arrow right and put in my x. So I now have log 3 of x. Y'all, when we hit graph, we'll see that the picture, and there it goes. It's sort of hugging that y-axis, crosses over at 1, and then heads uphill to the right. They're only going to have one picture that matches this stuff, okay? And y'all, really, that's all they're doing on the first 3 of these. You're just picking a graph. I got one for ln of x, so let me share that real quick. So if I was doing ln of x, I would clear this off and hit the ln button, and y'all put in the x, close parentheses. But y'all watch the graph. Is that graph not similar to the one I just did? They're all coming up, crossing at 1 and going uphill to the right. Okay, so we don't care what's in front of it. It's doing that. All right, so what I want to do is get into these exercises like number 4. Find the logarithm. All right, y'all, I got log base 6 of 1,296. All right, y'all, find me the exponent that you would raise 6 to equal 1296. So on this one, I would use my log base, okay? Or you can just start multiplying. 6 times 6 is 36 times 6 times 6. See how many times you do that? Oh, I don't see nothing popping up. So let's go work that one out, I guess. All right, y'all. So let me quit this screen. So log base 6, I would hit math. All right, I'm starting to see some answers. So Jackson, you're looking good on that. And so it looks like a 4. So you put your 6 in, arrow right, and put 1296. Hit enter. You get 4. So y'all watch this. 6 times 6 is 36. Times 6 is 216. Times 6 is 1296. So we had to do that 4 times. So that means this equals 4. All right, y'all. How about log base 8 of 512? So now we're looking for the exponent on the 8. How many times you got to multiply 8 to make that a 512? All right, good job. That would be 3. 8 times 8 is 64. 64 times 8, 512. Well, y'all watch this one. Log base 3 of 1 over 27. But hey, it's not a problem. We got our calculator. Now, we'll say this. When you get fractions like this, you're going to get special exponents. So y'all, let's go. Going to go to math, down to my log base. My base was a 3. My result was a 1 divided by 27, or you could make it look like a fraction by hitting alpha y equals and enter, and putting your 1 on top, 27 on bottom. So we can put these in exactly like they look. All right, y'all. Guess what? When I hit enter, you get a -3. Remember a while ago, I said if you use negative exponents, that was representing fractions in disguise, right? So here's the negative exponent. So 3 to the -3. Remember, you would make the exponent positive by putting everything under a 1. So you got a 1 on top, and y'all 3 times 3 times 3 on the bottom is 27. So fractional results will give us negative exponents. Oh, let's try one like this. This looks like number 9 for me. Log of 10. So remember, there's no base here. So technically, this base is a 10 on this. So I got a log of 10, which is really a log base 10 of 10. So this is one that you could do on the very front of your calculator if you wanted. But y'all, let's check this out. What exponent would I raise 10 to make it a 10? And basically, that's going to be 1 all day long. If this base matches that result, it'll equal 1. Y'all, I could do this. Log base 5 of 5. Well, log base 5 of 5 equals 1. 5 to the first is 5. Okay? So if the base matches the result, it always equals 1. What about a log base 3 of 3 to the fourth? What exponent would I raise 3 to make it a 3 to the fourth? And y'all, guess what? Y'all can punch that one right in that calculator, just like it looks. So I'd go to my log base again, so math, and scroll down. My base was a 3. My result was a 3 exponent 4. It looks exactly like that now. But think about it. What exponent would I raise 3 to so that it looks like 3 to the fourth? Well, y'all, when I hit enter, it's the exponent 4, right? If I want this base 3 to look like this result of a 3 to the fourth, that means this exponent here has to be a 4. Okay, so 3 to the fourth will equal 3 to the fourth. They just didn't make this 81. They just wrote it as an exponent. But check this out. if the base matches the base raised to an exponent, the answer is always the exponent. Okay? So log base A of A to the B will always equal B. So that's like a property you got to know, okay? Let's see. Let me try this one. Log base 5 of the 7th root of a 5. So let me show y'all how to convert stuff out of a radical into a fractional exponent. So this will equal A. Now, we can rewrite these radicals as fractional exponents. First, on top is the exponent of the variable. Well, since this variable has no exponent by it, you would treat it like a 1. So the 1 goes on top. That's the exponent of the variable. The bottom is whatever number's in the notch, and that's the n. So I can rewrite the 7th root of 5 as 5 to the 1 over n. Well, the n for us is 7, so that'll be 5 exponent 1/7. Now, I will show you another way to do this on the calculator, but you got to get good at being able to switch these radicals into fractional exponents. Use this property right there, okay? Now, let's go punch that in the calculator. But y'all, we know what this is going to equal, right? I got log base 5 of 5 to an exponent. What did we just say here? What will this equal? Because my 5s are matching each other like the A, and the exponent is good job, that would equal 1/7. Okay? All right, also get good at changing those radicals into fractional exponents. All right, let's see what we got next. All right, this one would be like number 12. Log of 10 to the -4th. So once again, this log does not have a base. So you're going to treat that base like a 10. So you got a log base 10 of 10 to the -4th. What's that going to give us? So good job. That's going to give us a -4. Y'all just remember, when there's not a number there, it's automatically a 10. So y'all, they do some. Let me go down here to 16. ln 9th root of e. Well, I'm going to change it out of this radical. So that'll be ln e. Well, I'm going to have a fractional exponent. So remember, the e don't have an exponent by it, so I would treat it like a 1 again. So the 1 goes on top, and then the index of the radical is a 9. So I put a 9 there. Also remember, ln is really a log base e. So this is really log base e of e to the 1/9. What will that give us? And sometimes if you just write this out, you remember that it's a log base e. So I got a base that matches the base raised to an exponent. And y'all, really on this one, you can punch that in on the front of your calculator. because the front of this calculator has that LN button right there. So I can hit LN, and then I'm going to hit second LN to get the E with the exponent. And my exponent was 1 divided by 9. And then I'm going to arrow down and shut my parentheses. Now you could have done the 1 divided by 9 and made it look like a fraction if you wanted to. But I'm going to hit enter. Now watch this. I'm going to turn that decimal back into a fraction by hitting math and enter twice. And y'all, we knew it was going to be 1/9 because the base matched the base to an exponent. That always equals the exponent. So y'all, the whole first half, that's all you're doing. You're just going to be figuring out stuff on your calculator. So now we're going to look at converting logarithmic and exponential. We're going to convert in between these two, okay? So to do that, we're looking at this property. The log base A result Y equals X. A double-ended arrow means if and only if. A to the X equals Y. So look here, the base, that's the base of the log. It equals the base of the exponential. Y is the result. Y is the result. And remember, logarithms find exponents. So this is the exponent. And that equals this exponent. So to rewrite them, if I want to go from log into exponential, I got my base A, my exponent X, that's going to equal that result of a Y. If I want to go the other way, the base of the exponential becomes the base of the log. The result of the exponential is the result of the log. And then the exponent of the exponential becomes the exponent or answer of the log. So we're going to use that to transfer back and forth, okay? So the first few we're going to say convert to logarithmic equation. So they're going to give you the exponential. So these will start around 17. So they're giving me 10 squared equals 100. So we're going to convert to logarithmic. So you got to write log. Now, when you write log, it'll make it bold and highlight it so you know you got it wrote right. Now, you'll use the little subscript. So what's the base of my log going to be? Well, the base is the same as the base of the exponential. So technically, your base is going to be a 10. The result is the result of the exponential, which will be 100. And log base 10 of 100, 10 to what exponent equals 100? Well, that would be that exponent of a 2. So y'all, you write it in logarithmic form and move on. All right, so 1024 to the 1/5 equals 4. All right, so same thing. You're going to come over here and write log. Your base is the base of the exponential, which is 1024. Our result is the 4. And log base 1024 of 4 gives me an exponent of 1/5. So y'all, I'm just following this exponential and putting everything where it needs to go in log form, okay? So then you got to go the other way. These next few say convert to exponential. So that means they're going to give you the log base 3 of 9 equals 2. This will be like 21. Whoops, let me pull that up. So exponential, you take the base, which is 3, the exponent, which is the 2. So you just got to remember, in logarithmic form, that's the base, exponent, result. And guess what? 3 squared equals that result of a 9, okay? Oh, I'm going to try this one. ln 25 equals 3.2189. Well, y'all, here's the question. To write it in exponential, what is my base? Let's see what y'all think. What is my base? Oh, you'd have to go on my notes. Well, now 25 is your result. Remember, I'm looking for what's the little base down here? If it's not shown on the LN, what did we say LN was? Oh, that'd be a log. So the log would have the 10 here. So y'all, let me refresh y'all. LN is a log base E. So when you see a LN, your base automatically becomes the E. So you would have a base of E. Exponent is the 3.2189. That'll equal your result of 25. Okay, so y'all, LN, you got to remember, LN is really a log base E. Okay, the regular log on the front of the calculator is a log base 10. And so you got to do a few of those where you got to rearrange them and have fun. Then they say, hey, use a calculator to find the common log. And they want you to round these 4 decimal places. So y'all, let's do one like 25. I want one of y'all to round this one off 4 decimal places and do me a log of 68. Now, this is a common log, which is a log base 10. So you can use the log on front of the calculator by the 7. So just punch in a log 68 on front of that and get me a decimal approximation. So let's see, 1.8325. So let me check you out. I think you're right. So what was that, a log of 68? All right, so I got three of y'all, two of y'all saying that. So it looks like 8325. Good job, y'all. Good job. So 1.8325. Y'all, that makes sense because remember, this is like a log base 10, right? Well, 10 to the first power is 10. 10 squared is 100. Well, since 68 is in between 10 and 100, the exponent has to be between a 1 and a 2. Okay? All right, so y'all did good on that. And how about this one, like 27? Do me the log of a negative 77. Oh, y'all ain't spitting that out too quick. Oh, so you're getting imaginary answers. You see how you got that 1.3644i? That means those are imaginary answers. So those is what we call does not exist in the real world. And y'all watch this. Log negative 77. If I hit enter, I get an error because I'm in real mode and all calculations must result in a real number. This tells me I got non-real answers. So that means in MATLAB, if you try to take the log of a negative number, it does not exist. So that, remember, if you get eyes on those, it's not real, so it does not exist. And y'all, that works for LNs too. If you try to do the LN of a negative 12, well, y'all push the LN in on front of your calculator. So here's my LN. If I do negative 12, whoops, I didn't do my LN. Okay, LN negative 12. All right, there I go. Same thing. Okay, that means you cannot turn a 10 into a negative number by using an exponent. You cannot turn an E into a negative number using an exponent. Those do not exist. Now, after this, they'll say, find the logarithm using change of base. What this means is use the math and then arrow down and get the log base. We call that change of base because we're not using the log base 10 on the front of the calculator, or we're not using the LN on the front of the calculator. So we call this a change of base. That way you can put in the actual number and the base. So like one example they had was like 31 log base 5 of 70. But y'all, when these are bases that don't multiply to get these numbers, you're going to get decimal answers, and they're going to want them rounded 4 decimal places. So let's go punch this one in and see what we would round it to, okay? All right, so clear that screen. All right, so I'm going to go to math and arrow down to log base. This will probably be your most important number in this chapter. So hit log base. The base was a 5. The result was a 70. All right, y'all, so we're going to hit enter, round it off 4 decimal places. So that'll be a 2.639. And let's see, the 7 has a 3 after it. So I'm going to keep that a 7. So that's basically what they want us to do is our math log based stuff when they say change a base. Oh, you know, I'm trying to look at so the last problem on here, number 35, is just a graph. So they want us to graph both functions using the same set of axes. So the same X and Y table. So one of them is exponential 5 to the X, and then the other one, so remember, logarithmic and exponential are inverses. So remember that f negative 1, that's our inverse x function, is a log base 5 of x. But y'all watch this. So here's 1 on the y-axis. We know what the exponential is doing. The exponential is going to come up on the left side, go through 1, and it's going to try to curve up. This is a log one. Well, we know that the logs are going to cross over the x-axis. So the logs are going to come up. It's going to try to cross that x-axis, and then it's going to spin out to the right. So I'm trying to put these pictures here. And let me zoom in a little bit on that. Notice there's only one doing what I need. It looks like this first one is a little bit low here. No, it actually looks like mine, right? It's coming along this, curves up, and then this side comes up to Y and curves over. Um, this one is backwards, it's going downhill. Let's see. C, the blue line's going wrong, and then D. But notice what this picture looks like, and notice what our picture looks like. Okay, so that would be my exponential and my logarithmic. So that looks like the same. It's coming up, and then this side's coming up with Y and goes up to the right. So the last one, all you got to do is graph them 2 functions in your calculator. So we could go to our calculator to get that. So y'all watch this. I'm going to clear out that one. So my first one was 5 to the x. So 5 exponent x. Now I'm going to come down here, and this one was a log base 5 of x. So I'm going to hit math, go down and get my log base, enter. That was a base of 5, and then arrow over and put in your x. All right, so watch the 2 lines. So there's the blue, there's the red. So the nice CE calculators will do them in color like that. The older 84s, they did everything in black lines, okay? But y'all, either way, we got the same picture on that, okay? All right, y'all, so tomorrow we will learn what we call properties of logarithms. So I'm probably going to do 9-5 tomorrow, 9-6 on Sunday, And then Monday, we'll come in and do the last section, 9-7. Okay, so I'm gonna spend a little more time in 9-5 and 9-6. Um, so where do you turn in to work for the test? So this is week 4. So either go to the week 4 folder under the homework lecture videos and stuff. Go to week 4 and you'll see a test 3 show work link. Now, if you cannot find the links that you need to upload it, email me your 4 problems like a picture or something, okay? All right, y'all, let me see here. Yeah, because Nat usually sends me her pictures, so that I'll take it either way, okay? All right, y'all. So 9-3, we looked at the exponential graphs, and then we moved them around, and you learned that one formula. 9-4, we learned about logarithms, which are really exponents, and how to evaluate those, okay? So, like I said, tomorrow we're going to look at properties of logarithms, and they mirror the properties of exponents, okay? Because remember, logarithms really are exponents, so they sort of follow the same rule as our exponents. Yeah, y'all are in week 4 right now.